When we're writing code, sometimes we want to make a decision if something execute some code if some expression is true, and execute another piece of code if this expression is false. So in that case, we can use something called the if-else statement. Here we have if and then an expression next to it. If this expression evaluates to true, it's going to go and do whatever is underneath the if. And then we use the else word, and underneath the else, we put another block of code, and this is going to get executed if the expression was not true. So here, this is a diagram of what's going to happen. So when you see the diamond shape, it means it's a test. The rectangles just means like statements that are going to be executed. This is called a flow chart, and it's a visual way of seeing what the code is doing. So here I come and I have a test. If it's true, it's going to go and do the body of the if. Whatever is underneath the if, it'll do. But if it's false, it's going to do the body of the else. And in both cases, it'll just continue execution with whatever code was after those two blocks. Okay. The same with the if statement. If you have more than one statement you want to do, you must put the curly braces around the true block and the curly braces around the else block. Let's look at an example. Here I'm creating a scanner. I ask the user to enter the numerator just like we did. We ask them for the denominator, and then I check. If the numerator is 0, this should have been denominator, by the way. If the denominator is 0, I should say it's not allowed. Otherwise, I will do the division. So let me just fix this, and I'll fix it on Blackboard. This should say if denominator is 0. Okay. So here we're trying to do something else. If the numerator is 0, I'm going to give them an error message. If it's not 0, then I'm going to find the answer and print it. So let's go to our code and try to do that ourselves, kind of like what we did. So I'm just going to comment out some code here also that we don't need. But let's come up here, and we can say here if it's a bad denominator, let's also comment this part out. So if you have a bad denominator, we're going to say you can't divide by 0. Otherwise, it's okay, and I can show them the answer. So I'll say system.out.println answer. I'll say numerator divided by denominator, and we need to make sure we cast it to a float. So this is an example of an if-else statement. So if I give a bad denominator, it tells me you can't divide by 0. If I give a good denominator, it tells me the answer. Okay. We can also use the ands and ors to do input validation. If I'm asking the user, let's look at this example. I'm asking the user to enter their grade. They enter a grade. And then I want to see if this grade is valid or not. So here I'm checking if the grade is less than 0 or the grade is greater than 100. Well, no one can get a negative grade, and no one could get over 100 if I don't give extra credit, for example. Then I will tell them that it's an invalid grade. Otherwise, I can also do an if check, and we're going to talk about this a little bit later in another slide, but I can do another check here. I'm checking if the grade is greater than 60 and it's less than 75, then I'll tell them that it's a C, for example. So we can use the or and to do range checking. So for example, here, if I say enter a number, let's go at the top, and I say system.out.println, enter how many hours you worked last week, and the user enters the hours, keyboard.next int. I can do a check if the hours is less than 0 or the hours is greater than 40. I can tell them like invalid number, for example. Println invalid. Enter a number between 1 and 40. use ORs for like or and for input validation also. That's one of the use cases for them. Another way you will see things written is using these question mark and colon. And this is just an abbreviated way. I'm not going to ask you to do something like this on an exam, but I want you just to know it so that if you see it somewhere, you know what it means. So basically you have an expression and then a question mark. So you're asking, is this expression true? And then after the question mark, whatever comes after the question mark, this is what we want to have happen or evaluate, get the value of if it's true, and then colon false. What does this mean? Let's look at an example. Here we have int n equal 10. So we're creating a variable equal to 10. And then what we're doing is we're saying next, another variable equal to, and then here I have a test. I have a test because I see a question mark. So I know that this is a test they want me to do. This is what it will get returned if this test is true. This will get returned if the test is false. So let's do this. 10. Let's try to evaluate it. What's 10 mod 2? Remember, mod means I want the remainder. So the modulus operator, that percent sign, gives me the remainder. So 10, when I divide 10 by 2, I'm going to get a remainder of 0. So here, if I have 0, is 0 equal to 0? The answer is yes. So 0 is equal to 0. So the answer is true. So it's going to go and evaluate the n divided by 2. What's 10 divided by 2? It's 5. So here, when I print next, I'm going to see that it's 5. Okay. Let's say n is 11, and I have this expression. 11, what will I get when I try to divide 11 by 2? What remainder will I get? I will get a remainder of 1 because it's not divisible. So 11 mod 2 gives me a remainder of 1. Is 1 equal to 0? The answer is false. So I'm not going to do the true expression. I'm going to do the false expression. So here when I say 3 times 11, I'm going to get 33. Plus 1, I'm going to get 34. And so this is an example of the conditional operator. Like I said, I'm not going to expect you to use it. I'm not going to ask you to use it. But if you do see it or you want to use it, I encourage you to do so.